So in this video, I wanted to illustrate another example of using row reduction using this app that I made. So rank again is the number of pivots you're going to end up having when you finish using row reduction. We already did this example, so let's go on to a different one. Let's go on to one that has more columns. And yeah, this looks fine. So what we would do is we want to find our pivot here in the first column. So see, dividing by 3, dividing by 4, dividing by 4, they're all not really going to be as well. Dividing by 4 actually is going to be nice in this column. So you see 4, 8, 40, 12, 12. These are all divisible by 4. So let's take this row, and we'll take row 3, and we'll replace it with row 3 divided by 4. So what would that be? That'd be 1, 2, that'd be 0, that'd be 10, that'd be 3, that'd be 3. So the point is that I have this 1 here, and once I get a 1, I'll move it all the way up. So let's do that. Click this, rescale this whole row. So that's what we have here. Now what we're going to do is we're going to interchange these two rows so that my pivot is up here on top. So we'll do row 1, interchange with row 3. So the way we do that is click these. So now we have our pivot here on top, just like we wanted. So we have a pivot on top. Now we're going to use this pivot to clear these out. We actually could have used the 4 before to cancel up the 4. We'll do that again afterward. Just a different way of solving it. So we cancel this out. And so how would we do that? What we do is, for row 2, what we would do, we take row 2, replace it with row 2 minus 4 times row 1. We're going to take negative 4 here, and then add it to this, so give you 0. So let's calculate negative 4 R1. So that would be negative 4 times this full row here. So negative 4, negative 8, 0, negative 40, negative 12, negative 12. So we're going to add that to this row here. So that's going to be 0. That's what we wanted, to turn this 4 into a 0. That's going to be negative 7. That's going to be 1. That's going to be negative 35. We're just adding negative 14 and negative 9. So this is what we should get for this row. So this row should turn into this number here. So let's see that. Turn this 1, and we're going to take negative 4 of them and add to this to make this 0. So we get 0, negative 7, 1, negative 35, negative 14, negative 9. That's what we wanted. Okay, so what would we do next? Well, we would take this row, this entry here, we turn this, take this and use this to get rid of this 3. So we would take row 3, replace it with row 3 minus 3 times row 1, because we want to turn this into a negative 3. That's this. And then add it to this to give you 0. So let's calculate negative 3 R1. So it's going to be negative 3, negative 6, 0, negative 30, negative 9, negative 9. And now we are going to add it to this. And this is going to be our new R3. So let's add them. We get 0. That's what we wanted. We want to use this 1 to make this into a 0. So that's this 0 here. Now we have adding. So this is going to be negative 7. Adding, or sorry, I apologize. Adding these. We get 1. Adding negative 35. Adding negative 14. Adding negative 9. So this right here, this new row, should be the row that we get for R3, our new R3. So let's see that. Take this 1 here, use it to get rid of the 3. So that's this row here. And you see it is identical to this row here. So now we have took this pivot here, we chose one of the entries, we turned it to 1, and we cleared out the rest of the column. So now what we're going to do is we're going to pick one of these, choose this to be our pivot basically, and we'll use it to clear out the rest of the column. So often what we'll do is we'll turn this into a 1 and then do the clearing. However, we see right away it would be easier if we just subtracted. So let's take R3 and we'll replace it with R3 minus R2. So this minus this. We see they're exactly the same row, so we're going to get all zeros. So let's just do the arithmetic anyway. 0 minus 0 is 0. -7 minus -7 is 0. 1 minus 1 is 0. This minus this is 0. This minus this is 0. This minus this is 0. So this row right here should turn into this row here of zeros. So let's see that. We use this -7 to get rid of this -7 here. And we have all zeros here. And you can see that it says matrix is row reduced. That's just referring to the fact that you have your pivot columns here. You have your little staircase of zeros on the bottom. And although there's a 2 up here, and although the pivot isn't 1 like we want it to be, that's what it means to be row reduced, basically. We're going to turn it into row reduce echelon form by dividing this whole row by -7. And then we'll use this 1 that we get to cancel out this 2. So what we're going to do now is we're going to take this -7, we'll divide through by this whole row, and turn this pivot into a 1. So we'll do R2. It's going to be replaced with R2 divided by -7. So it's going to be 0, 1, -1/7. And remember, 35 is 5 times 7, so this is just going to be 5. This is 2 times 7, so it's going to be 2. This doesn't have a factor of 7 in it, so we're just getting 9/7. So this is going to be our new row here. So let's do that. So we take this and we click it again to normalize the row. So this is a 1. So that's what we get here, 0, 1, -1/7, 5, 2, 9/7. So now we have our pivot here, just like we had our pivot here with all zeros. We have a pivot here with 0 here, but we want to turn this around to get rid of this 2. So what we're going to do is we're going to take this 2 and we'll subtract 2 of these away. So we're going to get R1 and we'll replace it with R1 minus 2R2. So let's calculate -2R2. So it's going to be 0, -2. This is going to be 2/7. This is going to be -2, so it's -10. -2, that's -4. -2, this is going to be -18/7. And what we do is we take this and we add it to R1. That's going to be our new R1. Our new R1 is going to do this, add it to this. So let's do the addition. That's 1. We don't want to mess our pivot up. So see that this is a pivot and it's still 1. We do this -2 plus 2. That's 0. That's what we wanted. We want to use this 1 to cancel out the 2. And now we just do the rest of it, the arithmetic. It's just 2/7. Here we get 0. Here we get -1. And we want to turn this into sevenths. So this is going to be 21/7. So 21/7. And then we add it to this. Well, this is 2 plus 1, that's 3. So this is going to be 3/7. So this right here should be our new row, our new R1. So let's do that. We'll use this 1 here to get rid of the 2. So 0, 1, 2/7, 0, -1, 3/7. So we have down here. So now we have our pivot here with zeros. We have our pivot here with zeros in the rest of the column. We have our row of zeros down here, and there are no more pivots. So we would look for pivots basically in this part of the matrix, this bottom part. There's no non-zero things so that we can turn to a 1, so we're basically done. And that's why this says that we're in row reduced echelon form. So suppose that this were a system of equations that we were trying to solve. And this was coming from equations like, a x1 plus b x2 plus c x3 plus d x4. I'm just listing all the way to x5. E x5 equals f. Suppose we had a system of equations like this that we're trying to solve. And the matrix that we had started with was an augmented matrix. So what we can do is we can just write down what the equations are that we can just solve for using this, that we get to solve. So this right here would be x1. This is the x1 column, x2 column, x3 column, x4 column, x5 column, and these are the constants. So there's 0 x2s plus 2/7 x3. Zero x4s minus x5. This is going to be equal to 3/7. This second equation says the 0 is x1s, x2 minus 1/7 x3, then 5 x4, and 2 x5 equals 9/7. So what we have is these pivot columns correspond to the variables x1 and x2 that we're going to solve for. And the non-pivot columns here are going to be the free variables. So x3, x4, and x5. So let's say x3 we'll call S, x4 we'll call T, and x5 we'll call U. That means if we take our vector x, which is x1, x2, x3, x4, and x5 in it, running out of space. Then what would that be? Let's write it here. So x1 is going to be 3/7. Let's kind of like skip to the step where we have the answer already. So here, this is going to be the constants. This is going to be the vector that have all the s's in it. This is going to be the vector that has all the t's in it. It's going to be the vector that has all the u's in it. So constants, 3/7. That's x1. Now, how many s's are in x1? That's x3. So when we move this over, we get minus 2/7. There are any t's, which is x4. There are no t's. There's no x4s, so we have a 0 here. What about u's? U's are x5. So when we move this over, we get positive x5. So that's going to be positive u, which is just 1. That's x1. Now what about x2? X2, when we move this over, so they're constants. That's 9/7. We move this over, we get x3 is s, so we get 1/7 x3, which is 1/7 s, so 1/7. And what about x4? This could be minus 5 x4. That's t, so minus 5. And what about u? U is x5. x5, when we move it over, we get minus 2u, so it's going to be minus 2. And these are the only equations that we solved for, x1 and x2. These are our pivot columns. So basically, the rest of these entries are going to be like zeros and ones. So x3 is free. It's just itself. So there is no constants, no t's, no u's, just a single s, which is itself, x3. Now x4 is just t. So that's t here. So it just has itself. There's no s's, there's no u's, there's no constants. x5 is just itself, that's u. So it just have itself. And then there's no t's, no s's, and no constants. And so this would be the answer that we have there. And again, the rank here is just the number of pivot columns that we end up getting. The number of independent equations that we get when we're done solving. This row of zeros here corresponds to the fact that one of the equations that we started with was redundant. So let's go back and we'll start over. We see here that one of the equations ended up being redundant. Remember what we did is we started with this row. We can just go through all the steps that we've done. Took this, turned it into a 1. We moved it up. And we have our 1 here, and we canceled this out. Canceled this out. We use a 7 to cancel this out. We turn this into a 1. We canceled this out. And then we were done. Now you can go through it in a different way. It should give you the same answer. So what you could do is you take this 4 here and cancel this out right away. And then turn this into a 1. And then move it up. So then we have our 1 here. This is already have a 0. We can cancel this out. And you see we get that same thing. These cancel each other out. And we should get the same answer here. As long as you put it in row reduce echelon form, it always has the same row reduce echelon form that you get, no matter what. Let's suppose that we start with this one, we turn this one into a 1. So let's get rid of this. And we'll get rid of this. We can use this to cancel this, turn this into a 1. Now there's some problems here with these stars, and that's just the bug for the app. Basically, some of the numerics, when you do a lot of division, it gets these small errors here. And I'm pretty sure that these should be zeros, which is a very small number that MATLAB is registering as not 0, exactly 0, but it is small enough that it's saying that there's a problem in terms of the way it's displaying it. So let's end it there.